Welcome to my garage, welcome to your garage, welcome to the garage of One for All. Yeah. Today let me try something different. Yeah. I know my idea of this channel is to communicate, is to spread the word about engineering, air conditioning and refrigeration, but I think some stuff we need to talk from the beginning. Will you join me? Okay, this class is hosted by me, Luis Lucchesi, the Garage of One World, and Springfield Technical Institute. Yeah, proud member of the institute. Yeah, proud founder member of the institute. So let's talk about science. Yeah, um, the ideas start from the very beginning. Yeah, and what's the beginning? The beginning is energy and matter. Yeah. Everything in the universe, what was ever in the past was ever created or ever will be, yeah. It's energy or matter. Yeah. No other thing. Yeah. But before to define what's energy and what's matter, we need to understand three fundamental laws in the universe. Yeah, rules, laws in the universe. In the future, we will talk about uh, how science define laws, theories, hypotheses. Yeah, but now take the three fundamental laws in the universe. Yeah, are the thermodynamic laws. Yeah, the first, nothing's for free. Nothing. Yeah. Like in every human relationship, like everything in the universe, nothing is for free. Yeah. We cannot do anything from nothing. We can make anything from nothing. Yeah. Energy cannot be created or cannot be destroyed. Yeah. If we are gonna to do something, we will need the energy to do it. Yeah. The energy exists per se from the beginning of the universe. Yeah. Second one, from the biggest to the smallest. I know scientists don't use these words to define the rules, but I think it's better memorized like this. Yeah. From the biggest to the smallest, the energy always flows from when we have more to where we have less. Yeah. Electricity. Okay, the electricity is in the plug in the wall. When we plug in anything, the energy is flowing from there to our device. Yeah. The heat. The heat always runs from the stuff that is hot to the stuff that is cold. Yeah. And the third one is the hard one. The entropy always increase. Yeah. Let me explain a little bit what is this word entropy. Oh, it's a hard word. No. Let me explain it. The idea of entropy is uh, the more um, the more possible scenario will be the one that will happen. Yeah. Explain. If I have a canister with, I don't know, a gas, a compressed gas inside the canister, and I open the canister, what do you think it will happen? Easy. The gas will explode and go out and just mix up with the air in here, maybe poison me or whatever. But the gas will go out from the canister, yeah, expand and mix up with the air. Okay, you just think, why do you know what it will happen? It's just because it's the most possible scenario. Yeah. Let me explain it a little bit. One of the scenarios were okay. We have trillions of particles inside of gas inside the canister. One will be to there, one will be to there, one will be to there, one will be to there. In another scenario, one will be to here, one will be to there, one will be to... If you see, there's a lot, a humongous world of possibilities that will show the same result. The gas is going out and expanding on the room and mix it up with air. Yeah, and we have a little few scenarios where we say, okay, the gas go like I don't know, like some kind of cloud traveling all together. Yeah, it's just uh, possibilities. Yeah, just this. Yeah. Okay, we know the rules with, about what is matter and what is energy. Now we know. Yeah, matter is everything that occupies a place in the space. Yeah. Everything that take a place in this place, it's matter. Yeah, the particles takes a place in the space. The particles that constitute our matter, yeah, they are occupying a space in this, a place in the space. Yeah, the Pauli exclusion principle, yeah, written by Wolfgang Pauli, says that two particles can be in the same place at the same time. Yeah, saying the other way, it's uh, matter is impenetrable. Matter takes a place, occupies a place in the space. Yeah, energy on the other side, it's everything that fits a movement. Yeah, electricity is the movement of electrons. Yeah, heat is the movement of particles. Yeah, uh, kinetics kinetics is the movement of huge bodies. Yeah, so energy is wherever that fits a movement. Yeah, so we say matter and energy cannot be created, yeah, or destroyed. So we can just figure that energy and matter exist at the same from the origin of the universe. Yeah, and will be the same at the end of the universe. Yeah, we can hear a lot about, I don't know, the universe will be a freezing death in the end of the universe. Okay, this is not because the energy is not there, but because the energy is so distributed in the universe that it's not enough concentrated heat to have something hot. Yeah, it's about the distribution, not about the quantity of energy. Energy will be the same from the beginning to the end of the universe. Yeah, no other way. But they are actually a thing. Yeah, I think we all know the this equation. Yeah, E it's equal m multiplied by c squared. Yeah, what is this? Okay, this is the mass energy relativity equation, yeah, written by Albert Einstein. Yeah, uh, and what that means? Okay, that means that E energy is the same like the mass. Yeah, the mass is the unit of quantity of matter that we have. Yeah, how much matter that we have? It's how much mass that we have. Yeah, multiplied by c. C is the light speed. Yeah, it's a constant in the universe. The light speed is the same in the whole universe. Yeah, square means that it's the light speed multiplied by the light speed again. Yeah, it's light speed times. Yeah, so they can change, but let me keep it simple right now. Yeah, uh, let's keep it like energy will be the same, the whole universe. Matter will be the same, the whole universe life. Yeah, that means the universe is just energy and, and matter. And that's the only what matters. Yeah. It's just a little joke. Yeah. But a lot of people will say, okay, but we have different energies. Uh, Electric energy is not the same that kinetic energy or heat energy or pressure. There are a lot of different kinds, different ways of energy. Okay. In this set of videos, we will be a lot of time explaining that they are just expressions of energy. Yeah. But the energy will be still the same. We can transform it from one way to the other. Yeah. And we will be a lot of time making experiments showing how can we transform one energy to the other. I promise. Yeah. This video, it's a lot of on the board, a lot of talking here quiet. Okay. Wait for me. Wait for it. We will be making a lot of experiments. A lot of experiments, I promise. Yeah. So finally, I want to say this just to end this video. Uh, the energy is just one thing. Yeah. All the energy is one thing. All the matter is one thing. Yeah. And all we will learn in the future will be related with this. Yeah. And keep in mind the three rules. Yeah. The three rules of thermodynamics. Nothing is for free. So energy cannot be created or destroyed. Yeah. Second, the energy always flows from where we have more to where we have less. Yeah. And the third, from all the millions of possible scenarios, we will have the more possible, the more probable uh, results. Yeah. Thank you so much. See you next time, and keep please do everything we all the YouTubers say. Just subscribe, put your like. Yeah, I promise we'll be funnier and funnier and funnier with the time. Yeah, thank you so much. See you next time.